All right, folks, listen to number 12. A rock is thrown upward from a level ground in such a way that, well, that's nice to hear, that its maximum height of its flight is equal to its horizontal rate. And okay, so overall, folks, I don't want to rant anymore. I'm going to try and do the problem and better communicate with you guys. But what I do want to get as, I want you guys to really be familiar with your equations before you even watch these videos, because that's really what's important here. That being said, let me just graph this, as I always like to do. So this is going to be the x-axis, and this is going to be the y-axis. And a rock is going to have this projectile pathway. It's going to be some parabola shape depending on what angle is thrown. So this is going to be the initial velocity that the rock is thrown. It's going to have some initial velocity, which we don't know. In fact, I don't know what variables is which, but let's see. At what angle is the rock is thrown? So they already defined this to be angle. Okay, theta. Such that its horizontal range, but they do give a scenario that its maximum height, whatever this maximum height is, if this is going to be a rock, and that's going to be r vector or L vector, I'm going to change that a little bit, such that the maximum height here, whatever this maximum height is, we'll call that h, is the horizontal range. So, okay, so that its maximum height of its flight is equal to its horizontal range. That's basically what they're asking for. So I'm going to define this to be, there you go. So I'm going to define this to be L, and I'm going to let L be the point X and Y. Yeah, and notice, folks, that I really don't have any of this planned out, so. All right, so, because I'm really just trying to set this up. It might make the video a lot longer anyways. So now we're going to let this, because this is the way I always like to do these problems. I like to set up the points. So X is going to be V naught cosine of theta times T. And that is the variable for X. For Y, it's really just going to be V naught sine of theta T minus G over 2T squared. G is specifically 9.8 meters per second square. So there's the equation right there. There's y in terms of x, x in terms of t. But they do give a scenario. We're going to let x be d when the time here is 0. But let me see. Oh, I see what this is. Okay. So we're going to give a scenario. We're going to do 2 cases, folks. We're going to find the time it takes for this to be the ground. So we're going to let x be d and y be 0. You're going to have your equation right there. So we're going to find the time so we're going to, the only unknowns is the velocity and the angle. But we're going to solve for the t, get this in terms of some velocity and the initial position. So you're going to need another equation. The other equation is going to be, so this would be basically d in terms of the horizontal range. Now we're going to let the horizontal range be the maximum height eventually. So once you got your one equation, I'm going to find the time it takes where this slope specifically is going to be 0 meters per second. In order to do that, we know that this final velocity is going to be the initial velocity, sine of theta, times the time, not time, so minus gt minus g of t. And we're going to let the final velocity be 0. And once you find that time, which here is just going to be v naught sine of theta over g, I guess I'm already solving it, we're going to plug it in to this equation to find where you equal the maximum height. And that's going to be your other equation. So you're going to have this equation right here, v naught sine, or unless there was some other kinematic equations that you guys plug and chug there, which is fine too. v naught square sine. I do tend to do it the longer way because I don't really know which method is which, but there you go. So this is going to be the time it takes for the maximum height. All I did is chug it in there, chug it into this original equation, came up with that, and then you simplify this, and now you got your other equation. So notice that this is the time it takes for the maximum height for the velocity to be 0. In this case, this is going to be the maximum height. So now we got your two equations. Now all we're going to do is mark up the other one, guys. So we're going to let this, we're going to take this other condition, we're going to let d, so that's going to be v naught sine of theta. We're going to let y be 0, so that's going to be 0 equals this times x over v naught cosine of theta. So that's going to cancel off x v naught, and then minus g over 2 x square over v naught square over 6 over cos square of theta. So that's going to be equaling 0. So you're going to have tangent of theta times x minus g over 2 b naught square, and that would be d square plus sec square theta. There we go. And that's going to equal 0. All right, guys, so now you have your two other equations. Now this doesn't look that pretty right now, but think about the unknowns that we have here, because in this case we only have theta and v naught and theta. These are the only two unknowns we have. We have d, we have h, we have the rest of it themselves. So what I'm going to do is I'm going to solve for v naught here. So I'm going to say that v naught square is going to be 2gh over sine square of theta. And the reason why I want to do that is because I want to get rid of that v naught. So now you're going to have this other equation. And this other equation is going to be tangent of theta times d minus g d squared over 2. You have secant square theta in there somewhere. And then now you're going to have this other one, which is going to be sine square of theta, by the looks of it. Oh, wait. So you're going to have 2gh over sine square of theta, which that turns in. So there you go. Once you simplify, you should get tangent square of theta. So notice that this whole thing is a bit involved in terms of just knowing your algebra. But luckily for us, we need to use the quadratic formula, because we can just divide by tangent of square of theta on both sides. So now, and even d. So now you have d, even though I'm going to keep that for now, g d square over, and I'm still wondering if I did anything wrong here, 4gh, which I might have. The g cancels off. The 4 is in there, so I'm not sure if that's true, but I'm going to go with the math here. And now you're going to have tangent of theta. So now you have tangent of theta. It's going to be, the g goes away, so that's going to be 4dh, or in this case, since this is going to be 0, so that's going to be, so that the d is going to be canceled, so that's going to be 1, 4h divided by d, I think. And is that it? I don't know if I did this right. Well, I'm about to find out. Well, folks, it looks like I did everything correctly. So you're going to have 10 inverse of 4, which is going to be the answer. So therefore, that's going to be theta. Theta is going to be specifically 76 degrees approximately. So it's The exact is 75.9637 or whatever the heck once you put the 10 inverse of 4 in there. But there you go, folks. I forgot how I did it. I don't know, but I know that's likely going to be the answer. So theta is going to be 76.0 degrees. That's part A. All right, folks. So for part A, the angle is 76.0 degrees. There we go. All right, let's see what part B. All right. What if, would your answer to part A be different on the planet? Well, it's always going to be 10 inverse of 4. So no, it would be the same on all planets, I would say. So 10 inverse of 4 is always going to be the answer that you're going to get according to the math. So I hope this helps you guys.